Hey folks, me again. So let's wrap this problem up. So I'm gonna have to construct the titration curve somewhere else on this page as we figure out what the pH will be once we've added even more base. So obviously at the equivalence point we have 9.07 for a pH. As we add even, and that took us 30 mils to get there. So in other words, we're just adding even more. So I'm gonna go back to the original ice table, construct it again. And if you're thinking, boy, this gets tiresome, I agree. So anyway, still got 15, we're going back to the beginning. So the original acid was 30 mils, it was 0.5 molar, so that would be 15 millimoles. Now we're adding 40 milliliters of sodium hydroxide, which is 0.5 molar. Well, 0.5 molar times 40 milliliters is 20 millimoles. That'd be zero, that'd be zero. Things will now change. We've only got 15 millimoles of acid, so both of these will drop by 15. Both of these will go up by 15, although water doesn't matter. We get to the end, we've got no acid left over. We've got 5 millimoles of base. We've got 15 millimoles of conjugate base. Now at this point, students usually ask, well, how do I know what's determining the pH of my solution? Well, it was easy here. I had no weak acid, so that's a no-brainer. I had no strong base, also a no-brainer. Water just has a pH of 7, so that's got nothing to do with it. I had conjugate base of weak acid. The conjugate base is therefore determining the pH of my solution, so I went through, figured out how many mils did it take to get there, what was the concentration then of the weak base, and then I solved it as a weak base problem, one additional. So notice this was very involved, unpleasant work, lots of steps, lots of chances to screw up, so you've got to really take those slow and careful. So this problem, what have I got? I've got strong base. And we just did this. This was weak base. And so back to students ask, well, how do I know what is determining the pH of my solution? And I don't mean to be too dumb here, but isn't strong base strong? Isn't weak base weak? And so we're going to ignore the weak base. It's going to have almost no impact on our pH. The pH is going to be mostly driven by our strong base here. So I need to know the molarity of my hydroxide at this stage. Well, I know I've got 5 millimoles. We took 40 mils of base, added it to 30 mils of acid, so I know the total volume is 70 mils. So I've got 5 millimoles in 70 milliliters. The millis cancel out, and I'm left with 5 divided by 70, which ends up being 0.0714 molar. Just want to make sure I'm reading that right. So 0.0714 molar. And so that's the OH concentration. So now to get the pH, I'm just going to negative log that. But that'll get me, remember, the POH, so I negative log. So negative log as I screw up the buttons. So I negative log that, 0.0714. And remember the pH, because this is 7.14 times 10 to the negative 2. The pH we know should be in the neighborhood of 2. But just less than, because this is not 1, it's greater than 1. And so the POH ends up being 1.145. I feel like I just misspoke there, but I don't have any of you to correct me here, unfortunately. And so then, therefore, the pH equals, I subtract that from 14, and I get 12.854 as a pH. And doesn't that make sense? Again, at the equivalence point, the pH was 9. Now we've added even more base, and the pH is now nearly 13. So if we sketch out a mini titration curve, Our next videos will be a deep dive into how titration curves work. So here would be the pH. If we put a pH of 7 right there, the pH of the solution started at 2.53, right? And we had 15 mils added, and then 30 mils added, and then 40 mils of added base. And so the pH at 15 rose to 4.7. The pH at 30 mils rose to this 9.07. And remember, before the lockdown, we pointed out how the pH skyrockets at the equivalence point. And then we go 10 mils past, and the pH rises to that nearly 13. And we end up with a curve that looks like so, where the equivalence point is here. We'll label that. And the half equivalence point is here. Those are two very important aspects of a titration curve, very useful aspects of a titration curve. So make sure you know where those are. You'll frequently be asked on the AP exam to either analyze a titration curve and label those parts, or you would be given those points labeled with a complete curve and then asked to utilize those in equations. So definitely know where the equivalence point is and its importance. Definitely know the half equivalence point and where it is and its importance. And so now I'll let you dig into one of the titration problems and attempt a handful of them in the homework problems. Again, definitely shoot questions at me through email or through Schoology, and I can either prepare a video or just answer you that way. Let me know. Take care. Bye.